is going on page 60 when we're done. Rational inequalities, along the same line as the polynomial inequalities, same concept, but we'll have to deal with some rational stuff in here. So it says, given a rational function, rational inequality has a general form of whatever f of x is, and then just all the inequality signs plus doesn't equal 0. Okay. And then, so if I have the inequality f of x is greater than 0, that is true when f of x is positive. See how easy that is? Isn't that what greater than 0 means? So if the function's greater than 0, then the function's positive there. And if the inequality f of x is less than 0, it's true when f of x is what? Negative. See, you got the hang of this already. Okay, so we're going to look at this and come up with our inequalities from a graph. We're mainly going to do it from just the function, the equation of the function itself. But I want to make sure that you understand what's happening. When we did polynomials, we ended up kind of like sketching it in there on our inequality. We're able to do the exact same thing with the rationals, but just so you at least understand what we're even doing with this. Now, in this graph, there are some asymptotes that are in here, but that aren't drawn in, so we're going to draw them in. And so if you go to x equals 2, there's an asymptote there. It's my vertical asymptote. And then at negative 3, there's also one. If there's any horizontal asymptotes, those don't affect us as far as the inequalities are concerned, so we're not worried about that, just our vertical ones. And so name the intervals for which the function is greater than 0, so that's when the function is positive. So this little part over here, function is definitely positive. So going from negative infinity to what? Negative 3. I never include my infinities. Do I include negative 3? No. Okay, because there's an asymptote there. And then from here, the function is negative. And then it's positive right here, so that's starting at negative 1 and going to what? 2, okay? Do I include the negative 1? What is happening at negative 1? What is the function value there? 0, okay? So if the function value is 0, it's not, exactly, we're not including that because that's not greater than 0, right? 0 is not greater than 0, and that's what we want. So it's not positive or negative, and so I do not include it. Does that make sense to you? Because I don't want greater than or equal to, I just want greater than. And then 2 is at an asymptote, so definitely not touching that, right? And then it's positive starting where? 4 to infinity. Don't include my infinity. Do I include 4? No, okay? Because at 0, it is not positive or negative. Okay, so you got a positive part of your graph, a negative part of your graph, and a 0 part of your graph. All right, so then name all intervals for which the function is less than 0. So it's negative here, starting at negative 3, going to negative 1. I don't include either one of those. And then it's also negative starting at 2 and going to 4. Okay. So this is going to be important to us when we go to graph these, and we can find our zeros, we can find increasing, decreasing, find our asymptotes, but then we're going to need to know where the graph is positive and negative so we know what's happening at the asymptotes. This says, notice that a rational function switches signs at both its zeros and its vertical asymptotes, okay, not just at the zeros like polynomials did. However, it may not always switch signs at the asymptotes. That's one of the reasons why we have to do the little signs, because if it always switched, then we just know it can, alternate. But right here, if this middle part of this graph was reflected and it had this shape instead, then it could be positive here. We have an asymptote and it stays positive. So the asymptote doesn't always change the sign, just like the 0 doesn't always change the sign if it's tangent. Does that make sense to you? I mean, it could, and it might, but that's what we're looking at, is if it's opposite on the asymptote or if it's the same, okay? And we'll get to that part later. So our steps are pretty much the same as the steps were for the polynomial ones. We move all the term to one side of the inequality, so 0 is on the other side. Find the zeros, this time of both the numerator and denominator by factoring. We plot them on the number line. Asymptotes always get open circles. Now, these were all technically open because it said greater than or less than. We're really just talking about positive and negative, which in the end is really where our concern is. But if the inequality that you have is greater than or equal to, then the zeros will have closed circles. But asymptotes, you're not going to touch that no matter what, so it's always having open. So on your number line itself, you might have a mixture of open and closed circles. Okay. And then we test the points just like we did before and write our solution. So we're not going to do every single example. We're actually going to skip 1 and 2, so you can go ahead and flip it over on the back. And we're going to start with number 3. Okay. Okay. So the first thing I have to do is factor. Now, how is a rational function, the equation of a rational function, different than the equation of a polynomial function? It's a fraction, exactly. That's what it means to be rational, right? Just want to make sure we're all on the same page. So these are called rationals because they're written in a ratio. You got a fraction, okay? And not just a fraction, but a fraction that has a variable in the denominator. Keep that in mind. All right, so I need to factor the numerator. Is that pretty easy to do? Yes. X plus 3, x minus 3, all over x plus 4. And that's greater than or equal to 0. All right, so then I'm supposed to find the zeros of the numerator and the denominator. When I find the zeros of the numerator, what does that give me? What is that? Well, yes, specifically that's the number, but like what in general, when I find the zeros of the numerator, what is that? Anybody? Because it's different than the zeros of the denominator. Is the numerator the asymptotes? The denominator is the asymptotes, right? So the numerator is what? The zero. These are the actual zeros of the function. And then the roots, same thing, roots, zero, solution. The denominator is your asymptotes. So when I find the zeros and I get that plus or minus 3, that is the zeros of my function, so plus or minus 3. Then the denominator, those zeros give me the vertical asymptotes. Okay, not just any asymptotes, but the vertical asymptotes because I also have other kinds of asymptotes, right? And those don't affect me right now. And so what would the vertical asymptote be? Do I just write -4? X equals -4 because this is a line. It's not a point. Like these are points that I would plot. These actual little, I'd go to -3. This right here is a vertical line. Okay, we good? So now that I find those, I'm going to put them on my number line. Now, I left these little number lines on here because I thought I kind of like that they're on there. And then after I made the copies and I was working through it again, I thought it's really not good that they're on here. Because depending on the numbers that you have, I'm going to have a -3 and a -4 that I have to plot, and they're really, really close to each other, which makes it hard to get the in-between part. So I would suggest if you have numbers that are kind of close, we're just going to draw, pretend like that's not there. We're going to just draw our own so we can space them out a little bit better. I have to put -4, -3, and +3 on here. So -4, -3, and +3, something like that. All right. Super accurate, but you need to have a look. Then I have to go and put the actual point on there. Would a -4 have an opened or closed circle? Open, because vertical, the asymptotes are always open, right? What about the negative? Closed. 0, but because this is greater than or equal to, right? So this is closed and this is closed. Everybody okay with all that? So then I pick my test points just like we did before. So I'll choose like a -5. When I substitute it in here, that gives me a negative. Here, negative. Here, negative. So negative times negative divided by negative is negative overall. Then I put in -3.5. That would give me here, would give me a negative, negative, and then a positive in the denominator. So what does that give me overall? Positive. And then 0, right? Just pick 0 itself in between there. That would give me positive, negative, positive, which is negative overall. And then a 4 would give me positive, positive, positive. And then, am I looking for when these are positive or negative here? Greater than 0. That's what I'm looking at, positive. So I shade in the positives. Then I also write it as an interval. So I'm going from -4 to -3. Does -4 have parentheses or brackets? Parentheses. What about the -3? Bracket. And then start back over at 3 and go to infinity. Infinity always has parentheses. What does the 3 have? Brackets. So make sure you're paying attention to your circles in there. This is my interval. And then my number line is part of my answer as well. Okay, everybody okay with that? Good. All right, let's jump to number 5. So on number 5, I've got to factor this. So when I factor the numerator, this is going to be x, and what do I end up with? X minus 4 and x minus 1, or the 1 come first, whatever. I said we're going to 5. Then when I factor the denominator, okay. Are we good with that?
Let's say for some example, one of the bottom is the same as one of the top. We can cancel them out.
Yes. So his question was if I can cancel them out, and the answer to that is yes, but that tells me something, and that's what we're going to talk about on Monday. On these, that will not happen to you yet, because you can't always just knock them out and ignore them because they do give us something. But in the end, they're canceled out. We don't use them, but we have to do something with them before they disappear. And so the answer to that is yes. That's one reason why you want it factored, so you can reduce this stuff. And then we'll talk Monday about what we do with the reduced stuff. It's a good question. Anything else? All right. So then from here, my 4 and 1, so I'm going to put 1 and 4. My vertical asymptotes, which we can abbreviate as VA as long as you know what it means. Okay. And how many do I have? I have 2. I have x equals what? 0 and x equals -2. Awesome. So here, I would say these as well. 0 and 1 are really close to each other, so I'm not using this number line. I'm going to make my own. And then on here, I'm going to put -2, 0, and 4. 2 open or closed circle. Open. 0. Open. 1. Closed. 4. Closed. All right, so then I start with like -3. So this would give me negative over negative. So altogether that is what? Positive. Negative times negative. Okay. So then I have -1. Give me negative, positive. So overall that's negative. Can put in 1/2. So that's going to give me negative, positive. So overall that's positive. 2 is going to give me negative, positive. Overall that's negative. And then I could use a 5. So it's going to give me positive. And they alternate again. Remember, that's not going to happen every single time, because if it did, we're wasting our time testing everything, right? So, all right, so then I want this. Do I want my positives or my negatives here? Negatives, because this is less than or equal to, so I'm shading the negative. I'm going to go from -2 to 0. Do I include -2? No. Do I include 0? No. And then I have 1 to 4. Do I include 1? Yes. Include 4? Yes. So here's my interval. That's part of my answer along with my number line. Okay. We good with that? Any questions? All right. I want you to work on number 6. Go ahead and get it factored. Work through the x's, the asymptotes. Just work through the whole thing. I'll start writing it up here in a minute, but I don't want you to even look at mine until you've got yours done, and we can, unless you're stuck and you have a question. You good? When you're done, see if you agree with me. Ask me questions if you don't. Do you feel like I'm missing brackets somewhere? No. You don't just automatically put closed circles on your zeros. On this one, it's just greater than. It's not greater than or equal to. That's why there's no brackets anywhere. They're just all open circles. Okay. We're good? Any questions at all? How's what? Okay, so I picked a 0. So it was +7, -2, +7, -5. Negative and negative is positive.
Oh.
Does that make sense? Okay. No, ask me a question. Oh, because I substituted 0 in here. 0, when I substitute 0 in here, this is going to give me a positive number. This is going to give me a negative number. This gives me a positive number. This gives me a negative number. I don't actually care about the number itself. With 0, I just said it because it's there, but that's all I really care about is the sign. Because you could have picked 1 and got this. You'd have different numbers with the same signs because we don't care about the number. Okay, anything else? All right, so we're going to look at 7 and 8 because these are not solved for 0, and we got to make sure we can actually do this correctly, accurately. So when I need 0 to be over here, that means I need x minus 7 over 2x minus 2 minus 1 is greater than 0. And I can't just leave it like that. I got to put it all together in one ratio because it's a rational function. So in order to have the fraction and something that's not a fraction and combine them, what do I need? A common denominator. And so my common denominator would be 2x minus 2. So this gives me x minus 7 over 2x minus 2 minus 2x minus 2 over 2x minus 2. It's greater than 0. Now, when I actually combine these, what do I have to be very careful with? The signs, right? Because this is minus this. So you can put it in parentheses. And remember, you can, when you distribute things, you can always change subtraction to addition. Always. And I know if you have x minus negative 3, you can go through and put plus or minus. You don't even think twice about it. Plus or minus. Plus a positive. You don't even think twice about it just because you've been doing that for so long. But even if I just had x minus 3, I can still change that to addition, make that plus a negative 3. Right? So, I mean, that's the concept of addition. Subtraction is just the inverse. You can always change it to addition. So here, I'm subtracting 2x minus 2. I can make that into plus a negative 2x plus 2. Maybe that's safer for you to do it right then. Maybe it's you put parentheses and you're fine. I mean, I don't know. Just do whatever you got to do so you're not messing it up. So then x minus 2x is negative x. Negative 7 plus 2 minus 5 over 2x minus 2 greater than 0. I still want everything factored all the way, right? So in the numerator, this is going to be a negative x plus 5 over 2 times x minus 1 greater than 0. So this is what I'm going to use. And since there's so much written around here, I'm going to put a little bubble around it. Then my x's then, what are my x values? Negative 5. My vertical asymptote, x equals 1. Okay. So on this one, I could actually use this number line. So we'll use it. You don't have to use them at all if you don't want to, but we'll use it. So my negative 5, is it open or closed? Open. And the asymptote's always open, so that one's open also. Okay. So then when I go in here, I'll choose like negative 6. Okay. Now, this negative outside makes a difference, right? Remember, that's like a negative 1. So even though there's one term up here, I'm looking at 2 different signs. You can look at it as just one sign if you want to. Just make sure you're thinking through it correctly. So it's going to start with negative no matter what, because I have to multiply whatever I get by a negative number. Negative 6 in here is also going to give me negative. And the denominator, I don't care about this sign because it's positive, so it doesn't affect anything. I can just ignore it. And then I just worry about this one, and this one also is going to give me negative. So negative times negative divided by negative overall is negative. Mm-hmm. If there was a negative down here, like if this was a negative 2, then you could do one of 2 things. You could cancel those out if you wanted to, or you would have to include it down here as well. And then it ends up canceling out anyway. That's a good question. Anything else? Negative 6.
Okay. So like if you put that in negative 6 twice, it's negative 1. And then you know the negative is positive.
Exactly.
So why do you have negative?
Because because the denominator is negative. So like this is just the numerator part. So you're right. If I substitute in a negative 6, I'm going to get a negative 1, right? That's this negative right here. And then it gets multiplied by a negative. That's this negative right here. I just took it out. So that's why I said some people look at it and go, okay, well, if I substitute in a negative 6, that's negative 1, but since it's times a negative, that's positive. And so instead of putting 2 signs, you would just put 1, and that's okay too. Okay, it works differently for different people, but that's absolutely fine. Okay, that's a good question. Anything else? Okay. So then I'm going to substitute in 0. Now this sign, I'm using, it's negative no matter what. Then this is positive. And then I put a 0 down here, and that's negative. So overall, that is positive. I can substitute in 3. This negative is negative no matter what. Then this is positive, and then this is positive down here. So overall, it's negative. Okay. We good with that? All right. So I want these. Am I looking at positive or negative here? Positive. So it's this part right here. So my interval is negative 5 to 1. And then they're both open. I also like my own number lines because then I can actually see the numbers. I thought it seemed like a good idea at the time, and not a good idea. All right, we good? All right, so And number 8, I am going to help walk you through it, but I want you to go ahead and set it equal to 0 and think about what you're supposed to do before I just jump in and start doing it for you. If you want to just go ahead and fix it and get it factored, and because you know you can do it on your own, that's fine. But I at least want to take a couple seconds for you to think about it, because it is something you should be able to do, but I think some of us might need a little reminder. So can I just do x minus 4 minus x minus 3 on the denominator and like cancel my x's out and stuff? Okay. Can I just go ahead and subtract the 9 and the 8? No. What do I have to have? Common denominator. Is it easy to figure out what your common denominator is supposed to be? Yes. I need to multiply this fraction by x minus 3 over x minus 3 and this one by x minus 4 over x minus 4. So this is going to be 9 times x minus 3 over x minus 4 times x minus 3 minus 8 times x minus 4 over x minus 4 times x minus 3 less than or equal to 0. So then when I go to combine them, I need to go ahead and distribute. So this is going to give me 9x minus 27. And then this is minus all this, so I'm going to treat this like a negative 8. So negative 8 times x is negative 8x. Negative 8 times negative 4 is a positive 32. Then in the denominator, I have x minus 4 times x minus 3. I do not want to multiply them together because I want them factored, so I'm wasting my time. Then I have, I can take care of the numerator. 9x minus 8x is x. Negative 27, positive 32. Plus 5, plus, hang on, it's catching up with me, plus 5, eventually, usually catches back up pretty quick. All right, so in the numerator, you have x plus 5, denominator still looks like this, x minus 4 times x minus 3, less than or equal to 0. Go ahead and find your zeros and your asymptotes, and draw your number line. Oh, good God in heaven, what just happened? Undo. Oh, there we go. Woo, it's back. I don't even know how that happened. All right, so x plus 5 over x minus 4 times x minus 3 less than or equal to 0. So this is the form that I'm actually using. It's fully factored. My zeros, what is that? Negative 5. Vertical asymptotes. Good. So x equals 4 and x equals 3. So once again, those are kind of close. So I'm going to draw my own. Got negative 5, 3, and 4. And then negative 5, opened or closed? Closed, because it's a 0, and this is, okay. And then 3 is open, and 4 is open. Okay. So then, we look at our signs. So if I choose a negative 6, that's going to give me in the numerator negative, and then negative, negative. So overall, that's negative. Between negative 5 and 3, I can pick 0. It's going to be positive, negative, negative. That's positive. 3.5 would be positive, negative, positive. And then 5 would be positive, positive, positive. And I want this to be what? Negative. So here are my negatives here and here. So I'm going from negative infinity to negative 5. And then from 3 to 4. Oh, I messed up. Where did I mess up? Bracket. Oh, dang it. Don't forget your brackets. Okay, any questions at all? We good? All right, so when you get the assignment, it is one-sided. It's supposed to be one-sided. That's not a mistake. I know you always question it, like something has to be wrong. It also starts with number 7 because I had editing issues, and once I at least got the stuff on there, I really didn't care what the numbers were. So